Okay, hey John, I'm recording this for you so you can see it whenever you watch it. All right, so we are doing number 24. Now if I can just write on the board, can you guys see anything? Okay, all right, here we go. All right, so we set that up. So you're going to get this theta, because we have the 1 square root, since it's opposite the square root of 3, we know it's 60 degrees. And it's going to be negative 60 degrees because we're going that direction. So the answer is theta equals negative 60 degrees. All right, is that one easier than the second kind?
Yes.
Okay, so that's A. I think the second type is not much harder. You just have to kind of start getting what they're trying to get to, which is hard. So they want you to find the sine of the angle arc cosine of, I really made those big arcs, brackets, -3/4 bracket. All right, we're not actually going to find, like when it says arc cosine, we're supposed to find the angle. But we don't need to actually find the angle, we just need to find the sides. We just need to be able to find the sine of the sides that make that angle. That's why it's confusing. So what we're going to do is we're going to make our triangle first. If it's cosine, then this is adjacent, and this is your hypotenuse. All right, remember with cosine, it's going to be between negative 180 degrees and 180 degrees. So the cosine is going to be in this quadrant or this quadrant. The reason it's not down here is because we can't get a negative value because we have all students take calculus. That tells you that the cosine is going to be positive in the 4th quadrant and it's going to be positive in the 1st quadrant. So it can't be in the quadrants that sine and tangent are in. So it's going to have to be in this quadrant. I'm just making a big mess. All right, so the hypotenuse has to be the positive one, so this is going to be 4. And the adjacent side is going to be this -3. And then all we have to do is find the third side by using the Pythagorean theorem. So we're going to get -3 squared plus 4 squared, plus b squared equals 4 squared. And so we're going to get 16 minus 9, so we're going to get b squared equals 7. B equals the square root of 7. And I got really jammed in here, square root of 7. So all you do for this part right in here, all that does is helps us to find our sides to our triangle. Now we just find the sine of theta. So we just use the sine. So it's going to be the sine of theta is just going to be opposite. So it's going to be the square root of 7/4, and that's the answer. So we don't actually find out what theta is. We don't find it. You don't need to find it because that's not your final answer. The one before that, whoops, I jumped too much. The one before that, where did it go? Yeah, this one right here. They wanted you to find, that's the bottom line right here. They wanted you to find the theta. The bottom line for this one, the one we just did, is finding sine of this angle. So I'm going to switch boards. That got so messy. All right, so we are on the next lesson, and we'll do the one that goes with that lesson too. Okay, 43. Here we go. 43. Oh, these are the sine curves and cosine curves. Okay, let's have a quick little review of this. Did you like the video that went with this? Hello? Did you like the video? Did you understand it? Anyone understand it at all? Okay, so if you're graphing a sine and cosine curve, okay, it's going to be, they're going to label it by quadrants. So this is 90 degrees, this is 180 degrees, this is 270 degrees, and this is 360 degrees. All right, so if we were to find the sine of 0 degrees, If you thought of the unit circle, I mean, you could put it in your calculator, the sine of 0 degrees. So if you push sine 0, you're going to get 0. Okay? If you're thinking of the unit circle, let's review everything we've learned before that Saxon doesn't teach you. So this is going to be 0, 1. This is going to be 1, 0. This is negative 1, 0. And this is 0, negative 1. Okay. So remember how I told you that the first number in the ordered pair is going to be your cosine number, and your second number in your ordered pair is your sine number. So if you had to find the sine of 0 degrees, well, it's just going to be this degree right here. I mean, it's not going to be any, it's not going to go up or down. So the sine of 0 degrees is just going to be the second number, which is sine. If I said, what is the cosine of 90 degrees, what would you say? Anybody? 0, because the cosine is the first number and the sine is the second number. And tangent would be opposite over adjacent, so it would be sine over cosine. So if I wanted to find the tangent of 0, it's going to be 0. If I'm going to find the tangent of 90, it's undefined because you would be dividing by 0. 1 over 0 is undefined. All right, this helps us a little bit with our curve, and our curve will help us with our quadrantal angles. It all works together to help us. Okay, this is as if you're taking the unit circle and you're putting it on a graph. So we're unwrapping the unit circle. So when you do the sine, if this is a sine curve, if you do the sine of 0 degrees, it's 0. So we put a point there. The sine of 90 degrees, if you look at the ordered pair, it's going to be 1. The sine of 180 degrees is again going to be 0. The sine of 260 degrees is 1. This thing is negative 1. Yeah, look at that way down there. And then the sine of 360 is going to be 0 again. And so, so it's just going to be a curvy thing like this. And I won't do it good, but you know what I mean. All right, so that's the sine curve. And you can picture it in your head. So anytime you think of, okay, what's the sine of 0 degrees, I like to think of it on the sine curve always starts out at the origin. So when you hit some of those problems where it says, what's the sine of 90 degrees, I like to think of the sine curve, because I know the sine curve starts at 0, so the sine of 90 would be 1, like that. Okay, this is called, the distance from here to here is called the amplitude. Okay? That's the amplitude, it's how high it goes. So if I have y equals 2 sine of theta, instead of this going to 1, it's going to reach up to 2. Now we're going to be shifting the curve all around and flipping it as well. But if I said like y equals negative 2 sine of theta, we're going to flip it. The whole thing flips. So instead of it being, if I'll put a 2 down here, this would be negative 2. Instead of it being 1, it's going to be negative 2. It's still going to be 0. And at 270, it's going to be 2. And so the whole thing stretches out, but it's going to go this way if it's negative. Whoops. Like that. That would be negative sine of negative 2 sine of theta. Okay, do you guys get that? I'm sure that's what he kind of taught you, right? Yeah. And then, just real quick, the cosine, if we did the cosine curve, these get really, really tricky. That's why I want to make sure you get it when it's really easy, because it gets really tricky. All right, so cosine is, here we go, let's get our 1 and our negative 1. Then we have our, I'll just make these a little bit smaller, 90, 180, 270, 360. 270, 180, and 90. Now if you look at this little chart that I made over here with the ordered pairs on it, the cosine of 0 is 1. So cosine is going to start up here at 1. It's really just the sine curve shifted over one place. See, if you took the sine curve right here and you shifted it over, it's the same thing. It's just all going to be shifted. The shifty thing is going to be tough. That's going to be the hardest part for you guys, shifting. And the periods are going to change too. So this one's 1, so it's going to be here 0, and then it's going to be -1, and then it's going to be 270, and then it's going to be 360. So I don't like doing cosine curves. I think they're really hard to draw. They're not as fun looking at all. Even though if you continued it would look like a sine curve. Now, if you look at the sine curve, one more thing before you do your problems, see how this sine curve goes around, and it comes down, and it comes around, and it starts at the beginning? That's called one period. So in this sine curve, you get one period in 360 degrees. There's times, though, where we're going to get 2 periods in 360 degrees, and it's going to look like this. And we can get 3 periods in it. So we have a lot to look forward to when it comes to these curves. All right, let's go and try our problems now. All right, so first one was number 1, 43, number 1. Do you know I hate doing word problems? I know, it just never changes, you know, your whole life. Some people might like them. All right, this one's an old problem though, so this one's not bad. He measured the angle between the base of the building and the top of the building. So here we go. We're going to draw our lines. There's the building, right? And here's our distance.
I like these ones.
Yeah, this one's not bad actually. And here we go. We make a triangle. It's not very drawn to scale. Okay, but at least my lines are straight. So the angle is 0.5 degrees, which is tiny, tiny, tiny. Like, that's crazy. Such a small degree. It's a half a degree. I can't even draw a half a degree. I guess I could have drawn this down lower like that or something. Okay, then this is 5,000 feet. And we want to find this distance right here. And thankfully, we know our trigonometry. That's how we did these in Algebra 2. So we don't have the hypotenuse, so we can't use sine or cosine, so we're going to use tangent. So we'd say tangent of theta equals opposite over adjacent. So the opposite is x. Well, x over 5,000, right? So we'd say the tangent of 0.5 is equal to x over 5,000. So we just take 5,000 times the tangent of 0.5 equals x. And you just basically put that in your calculator and you get 43.63 feet. So the building's like really tiny. It was more like probably more like this, like that kind of thing. And that would give you the 0.5 degrees and then the building. All right, does that make sense, Emily? Yeah. Yeah, those aren't bad. Were you thinking it was more of the circular degrees with radians or something?
Yeah.
There's nothing circled here, like nothing curved. So you just do the old one. Okay, that was easy enough. Number 3. 3, what is 3? Okay, one of these yucko things. 10 workers could do the job in 12 days if 8 workers worked 5 days and then half of them quit. How long would it take the rest to complete the job? Okay, whenever you see worker and days and all that kind of thing, it's one of these, let's see, rate, worker, time equals job dealios. So you have 10 workers, 12 days. We don't know the rate. 10 workers, 12 days to do one job. So if you have 10 workers working 12 days, their rate is going to be 1 over 120 jobs per worker hour. Worker hour. Because this is your worker and this is your hour. So when you divide by 10 times 12, it ends up being worker hours. All right, you got that part? Okay, all right. So now we have, some of the workers are going to work, and then we're going to lose half our workers, and they still have to complete one job. So we have rate 1, worker 1, time 1, plus rate 2. The rate's going to be the same. Worker 2, time 2. So the rate is going to be 1 over 120. That's how much each worker works. You have, it starts out with 8 workers in 5 hours. And then we don't know how long it's going to take. If we have, the rate's going to be the same. Each worker still works 120, takes 120th jobs per worker hour. And we only have 4 workers this time, and the time is what we don't know, so we call that T. And that's still going to equal 1 job. So we do all of our mathematics here. 5 goes into 120. Okay, 5 divided by 120 is wait. What am I thinking? 5 goes into 120, right? 120 divided by 5 is 24. So this is going to be 24, and so this is going to go in, I wrote 25. This is going to go in 3 times, so it's 1/3 plus, this goes in 30 times, 1/30th T equals 1. And so if you do all that math, you get T equals 20 days. And that's your answer. Yep. Okay. You guys okay with that? Okay. Those are weird. I'll try not to give them on test. I'll try. Well, it gets worse. Those are possible if you kind of study it and figure it out. But the next lesson is called abstract rate problems. Yeah. And I won't put any of those on a test. Those are just incredibly stupid. Yeah, wait till you see it. I mean, watch the video for it tomorrow and, try the problems the best of your ability. Yeah, we have some interesting things coming up. Things are taking some evil turns. Okay. All right, where were we? That was 3-9. Number 9. There's always such interesting sounds in the background. Okay, never know what's going on. It's like it leaves it to your imagination. -2, 3, radius equals 4. Okay, you are to write an equation of a circle. That was 2 lessons ago, right? When did you learn that? It wasn't this lesson.
A while back.
A while back? Okay.
Like 39.
Okay, so there's
Not too long ago.
Yeah, these are really easy because you just have to memorize the formula for a circle. So a circle is x minus h quantity squared plus y minus k quantity squared equals radius squared. Whenever you see that, you should say, oh, this is a circle. This is a circle. All right? So when you see that formula, h and k are the center of the circle. That's the center. So this is the center, so this is your h and this is your k, and this is your radius. So all you have to do to write an equation of a circle is to put, is this standard form? Yeah. So you just stick it in. You put this in for h, so it's going to be x minus a minus 2 would be plus 2 squared plus y minus 3 squared equals 16. I think that's it. Is that the form they had it in? Yeah, that's your answer. They actually don't have it as, I guess it's the standard form, you just leave it as 4 squared. Because that's your standard form. It's in this form right there. So that's all there is to 9. Number 19. This was a fast day. Okay, quadratic equation with lead coefficient 1, whose roots are 1 plus the square root of 3 and 1 minus the square root of 3. So these are your answers, and you have to come up with a quadratic equation. Like if they said the roots were 2 and 3, you would say x minus 2 times x minus 3 equals 0, and you'd say x squared minus outer and inner would give you -5x plus 6 equals 0. So this would be your answer to that. If they gave you these roots, you work backwards to get the equation. So that's all we're going to do here. We're going to take these, we're going to subtract them from x. So you have x minus 1 plus the square root of 3 times x plus 1 minus the square root of 3. Wait. Never mind. I don't know where I got the plus. X minus 1 minus the square root of 3. So you subtract both of these roots from x. And then you have to FOIL it. You can do it 2 different ways. You can either I don't know which is the best way to do it. I'm just going to FOIL it in parentheses. Let's try that. You could either distribute the negative through and then do that long way, or you could try FOILing it. I'm going to try FOILing it, see if it helps. So I'm going to do my first term, so I get x squared. Okay, now these are both not the same. So your outer is going to be negative x times 1 minus the square root of 3. Your inner is going to be negative x times 1 plus the square root of 3. And our last is going to be plus 1 plus the square root of 3, 1 minus the square root of 3. Do you guys understand how I just did that? Okay, so this is our first. You get the first, right? First, okay, outer would be these two guys. And that gives you this. It's going to be negative x times parentheses. Your inner is going to be x, oops, yeah, it's still going to be negative because it's going to be x times negative 1 square root of 3, gives us this guy. And then our last is the parenthesis times the parenthesis, which gives us this. So then you just distribute it all through and you get some messy muck. So x squared minus x plus the square root of 3 minus x minus, oops, this should have been an x there. Forgot that. Minus x square root of 3. And then when we FOIL it, your outer and inner add out, which is beautiful. So you get 1 minus 3. Because the square root of 3 times the negative square root of 3 is just negative 3. Outer would be square root of 3, inner would be negative square root of 3. So the other way around, they add out. You guys get that? Okay, we have that random x. Okay, we have two random x's. So here we go. So we get x squared minus 2x minus 2x square root of 3 plus. Do they? Oh, that's nice. Oh, then life is so nice. Look at that. Beautiful. Okay. So these guys just kill each other. So we get minus 2 and equals 0. I lost him along the way somewhere. Okay. And so that's your equation with these solutions. So if you were to put this in the quadratic formula, that's what you would get. Of course, I didn't check it with the book. 19. Okay. So if you put that in the quadratic formula, you would get these two solutions, or you can complete the square, which we don't usually do. All right, 19, last one, 25. Yeah, you don't want to forget this guy. Hey, I wanted to do one of those ones, not to belabor this, but you guys, I want to do number 12 for Risa here. And then we'll do 25. So 12 is secant of negative 3 pi over 4 minus cotangent of pi over 2 plus cosecant of 3 pi over 2. We'll just do this together real quick. So first turn it into degrees. So all you do in your calculator is you take 3 times 180 equals, divide by 4, and you get 135 degrees. So it's going to be the secant of, I can do these really fast, so don't panic, negative 135 degrees. Then we have the cotangent, and that one's going to be what? How many degrees? Do it in your head. 90 degrees. And these are all like inverse operations, so there's even worse than normal. 3 pi over 2, so it's going to be 270. Because I just took, if this is 180, I just took this and made it 90, and then 3 times 90 is 270. All right, now we don't even have to subtract any of these from 360 because they're all under 360. So let's just quickly make little charts for all these guys. So this is negative 135 degrees, so it's going to be here. It's not going to be there. Yes, it is going to be there. No, it isn't going to be there. So it's going to be over here. So this is going to end up being 45 degrees. And we can put our 1 square root of 2 on there. Secant is opposite of which operation? Okay, cosine. Because you don't, cosecant and cosine don't go together. That would be nice if it did. It would make a lot of sense, but no. Secant goes with cosine. So it doesn't really matter which one it is because it's going to be the hypotenuse over 1. Okay, and one of these is going to be negative. These are both going to be negative, but this is going to end up being negative. Okay, do you see why it's negative? Okay, because it's your, this is really 1 over cosine, and this is all students take calculus, and cosine is negative in this quadrant, so it's going to be negative. Okay, cotangent of 90. Now this is the one where you go like this. You put your point up here like this, and you're going to get, this point is 0, 1, right? And tangent is opposite over adjacent, or it's going to be tangent is y over x, or you could say tangent is sine, yep, we're going to flip it, sine over cosine. Those are all the different ways you can write tangent. So we're going to flip it, so it's going to be cosine over sine, so it's going to be 0 over 1, so it's just going to end up being, I got to erase some of this, can't fit it in here. So it's going to end up being 0. So plus 0. And then this is going to be another quadrantal angle. So I like saying that word, quadrantal. Sounds like a dinosaur or something. So this is going to be 0, negative 1. It's the opposite of sine, so it's 1 over sine. So this is your cosine, this is your sine guy. So it's just going to be 1 over negative 1. So it's going to be negative 1. Okay, Risa, does that make sense to you?
Mm-hmm.
So it's going to be negative 1. Let me just check my answer real quick. 12, yes. Yep, so it's just going to be negative 2 minus square root of negative 2 minus 1. That's your answer. They're not nice. The book does them really crazy. Do you ever look at the book? They do this flipping thing, which like adds extra steps. So you don't need to do that. Okay, let's go on to our last problem, and then we'll be done. So, and then I'll stick this up on YouTube for John, because I don't know how else to put these things up besides YouTube. Are we on 25? 25, okay. Okay, this one is the arc sine of negative 1/2. So we want an angle this time. We don't want just, there's nothing outside of this, so we want an angle. So arc sine, so sine would be opposite over hypotenuse. This one looks bad. No, it's 1/2. This isn't bad at all. Okay, so we just draw this, y, x. Remember, sine is in these quadrants. So we're going to, our hypotenuse has to be positive, so it has to go down here. So this is our negative 1. This is our hypotenuse. This is our square root of 3. So what's the theta going to be?
It's negative 30.
Negative 30, because it went down this way, and so we're going to get theta equals negative 30 degrees. All right, so those I think are pretty easy in general, because you only have like 3 choices, 30, 60, 45, or you could have the negative version of them all. Okay. Oh, part B is easy? Okay. All right, because it's the 3, 4, 5, right?
Part B was the one that I didn't get.
Okay, so you have sine of arc sine of negative 3 over 5. So this time we don't come up, there's not going to be any degrees. We are going to find a ratio, sine, cosine, tangent, or a ratio of sides of triangles. So the only reason we do this is because in order to do sine, you have to have hypotenuse and you have to have the adjacent. So we're going to set up a triangle, opposite I mean. So we're going to set up a triangle so we can figure out the opposite and adjacent. Now this one is weird. So this is the opposite, and this is your hypotenuse. So yeah, this one's kind of really easy. So y and x. So sine is going to be in these 2 quadrants, so it's going to be down here. So opposite is going to be negative 3. We don't care about adjacent because we're doing sine of a sine. So we're going to learn something here. So this is going to be 5. This is a 3, 4, 5 triangle anyway, so this would be 4. And then you just have to find the sine of theta, which this ends up being theta, now that we have it set up. So the sine of theta is going to be opposite over hypotenuse, so it's going to be -3/5.
Yeah.
So if
They
you,
gave you the sign of it.
I know.
Like I went through all of that too. I was like, wait, they gave me the sign, so it's just.
Yep, yep. So if you take the sine of an arc sine, it's just this, they kind of cancel each other. It's kind of like going sine times 1 over sine, because the arc sine is just kind of the inverse, so you're just going to get the number. All right, so boy, this is the first time we finished early, I think, ever in this.
Yeah, and you didn't have to add any time.
I did. I added it, but I didn't need to. Yeah, maybe because we didn't have John's questions either. We need to get on him to add his questions. Okay, so we have. I'm gonna have to email you your test for the next time, and I'll have to email you your test results back too from the last test.
To give you my test last time, so.
Okay, I was gonna look at them tonight because I always do them Wednesday nights. Yeah, send it tomorrow, and then I'll just grade them next week. Yeah.
Yeah, I'll send it with Ben.
I know. I was trying to track you guys down. I was losing. It was the week before the wedding, and I wasn't thinking very well then. So, all right. So I guess that's it. So I'll unrecord myself, and so I don't keep talking all day. I did that for an algebra class. I kept recording. I didn't realize it, and so for like 20 minutes there was just like house talking in the video. Yeah, I know. They told me. I didn't even know I did it. They're like, we could hear you guys talking in your house. So, all right. Well, apparently, yeah, people don't have much to do, I guess. No, there was nothing to watch. It was like just listening. My screen was recording. So, all right. Well, yes, and I'll see your test tomorrow then, Emily. All right. Bye-bye.